Howdy. Last video was a little long, so hopefully this one will be a little shorter. In class, on the 15th of January, we talked about lines and how to define lines in a vector form. So we got this equation eventually of u vector plus t times the v vector, t being just a scalar. Here's how we got it. We say we had 2 points. There's a line that connects those 2 points. And where there's a line between 2 points, there's a vector. We'll call that vector v. Say we had another vector from the origin to the a point, or the point on there, the line. This means that if we added u and v, we would get that third point right there. But say we wanted a point other than that on the line. How would we get that? So what if v was just a little bit longer? So if it was that long, then it would just be u plus v. So to make v just a little bit longer, or however longer we want, we just multiply it by a scalar. And that's why that works. It's a u plus v times a scalar. So whatever that is, if it's back here, over here, whatever the scalar makes it go, creates that line. And that's why that works. Why do we need this? Well, the answer is R3. In R2, on this two-dimensional plane, it's simple to define lines and see lines and things like that. But when R3 happens, lines like that then become planes, because it's extended another dimension. And so just to have a line in R3 is more difficult. So what we do is we write things more like in vector format to define lines in R3 because it's simpler. This equation is still in R2, but it's a good example of we take u1, whatever that is, u2, and that's I hat, j hat, and that's the u vector, and we still add it to t, or a scalar, multiplied by the v vector, so v1i plus v2j. This still is coming back to our old equation, u plus tv, u plus tv. So what we do in this case is we factor in that t and then combine the same directions, so I, j, and j. And what we get is u1 plus v1t, I, plus v2 plus, or that's a u, u2 plus v2 t, j. What this makes it do is that I is a direction and j is direction. And the pretty standard direction for those is I is equal to the x direction and j is equal to the y direction. So what we can do is we can create a systems of equations where we have x is equal to the I direction and y is equal to the j direction. So what we've done is we've taken normal, what would be just numbers, and put an equation in for it instead. That way we can define a line wherever it is instead of just a single vector or point. And so this allows us to, and then we break it up and we have a system of equations. And then if we knew u and v and u1 and v1 and u2 and v2, because those are just numbers, then we could find t easily. And this would tell us intersection of lines between y and x. So there's a lot of problems that are given to us with in lines in R3. So first things, just some things we should think about. If given 2 points, so the problem gives you 2 points, you want to subtract them. The z from z, the x from x, the y from y, or the I from I, j from j, k from k, and so that you find this vector from the origin. And what that will give you is that will give you the v vector here. You had a point there and a point there, and you subtract them, so you get this v vector. Why you need that is because it gives you the direction of that line, or the line that we're really going to define. You're going to multiply the vector obtained by subtracting 2 points by t. That's not an I just underlined the t. By t, or whatever scalar you want. I think it's mostly called t because of time, and this deals with parametric equations. Okay, in these problems, you want to think. I need a vector describing the direction of the line. So I need, describing the direction of the line, I need a v. I need a v vector. And so if you're given 2 points, find that. If you're already given the vector, then great. Okay, so first I need that vector. I also need a vector from the origin to a point on the other vector. So in this case, it'd be u. I need a vector to there, or to there, but I need to know that point. So origin to a point. Then multiply by t, by some t. So you want to multiply v by t. Oh, and then add them together. So those are kind of the 3 things that you want to think about. So here's another hard thing that I think showed up in class was intersection problems when you have 2 intersecting lines. First thing you want to do, I'm just going to go through the process of solving one instead of solving one. I couldn't really come up with one on my own. That'd be really hard. So to construct a vector from, first thing you want to do is construct vector form equations. That's what that says. I can read. Construct vector, except my handwriting's pretty bad. So you'll have as many equations as lines that you have. So if you have 4 points, you'll probably have 2 lines. If you have 6 points, you'll probably have 3 lines, either one. But you'll come up with vector form equations that look something like this. This just says L of t, but you could probably write anything in there, you know, x of t, or you could just put L for the line labeled L, anything like that. And you do the same thing that we did back here. For here, you had a vector plus that, and then you just put all the same directions in the same spot. So that's what's been done here. We have 1 plus di, all the j's are together, and all the k's are together. This makes it so you could break it up later, and we'll show that. So you'll have other lines too. So you could have an S, a W, or whatever. Don't use the same variables in the separate equations because they are independent. It'll make answers unsolvable. Because if you have a t in this equation, and then you have another equation that has t, when you set them equal to each other, you have a t equals a t, and you'll just end up crossing them out, which is not correct because you need that t. You need the value of that t is what you're going to be looking for. You also want to set the directions equal to each other of the separate equations, meaning the I is equal to the I, the J equal to the J, or in other words, X is equal to X, Y is equal to Y. And then you'll create a system of equations like shown here. So we had one equation, I is equal to the other equations, I, direction, J to J, K to K. And then we have 3 equations with only 2 unknowns, so this makes it easier. If we had 3 unknowns, then we could solve it anyway. You always have the same number of equations as you do unknowns. So we solve for here, and then we find the answer. Last thing to say, though, if the variable's answers, so say t is equal to 4 and s is equal to 1, if they don't satisfy all the equations, so say these top 2 are, we solve for these 2, and we get that s is 4 and t is 3, if that makes it so this equation is not true, then the lines do not intersect and the lines are skew. And in R3 they will not intersect. So there needs to be all 3 equations need to be true with the value to the variables that you find. Then a little change of subject. Say you want to create an intersecting line with 2 vectors that already intersect, or you have 2 lines that don't intersect, but you want them to intersect. What you're going to do is you're just going to take the cross product, and you have a third intersecting line, or a line that intersects both of them. Any 2 vectors that you take, when you take the cross product, it'll intersect them. So that's just, if you want them to intersect, you'll take the cross product. Okay, I said it'd be shorter, but it wasn't. But hopefully it was useful. Thanks for listening.